So today we're going to get into the compound interest formula. Now our compound interest formula is this right here. A equals P times 1 plus R over N raised to the NT. So this here is going to be very important today. It's what's known as the compound interest formula. So let me just talk about kind of what this means. So in this formula, our A, that represents the kind of like the ending amount. So I would kind of call that our ending amount. Okay, so it's like how much money is left in our account after a certain amount of time. Our P is what's known as the initial amount. Okay, so it's like if I invest $1,000 into an account, that $1,000 is my initial, so that is going to be my initial amount. This R is going to be the rate. And in most cases, that has something to do with our interest rate, because we're talking about how much money do I make over a certain amount of time. T is the time that the money or whatever we're putting into our account is going to be there. And N is probably the most confusing part about our formula, but it's known as the compounding rate. And the compounding rate is essentially how many times do I calculate my interest within my given time interval. So we're going to have things like compounded monthly, compounded daily. And so if I said I wanted to compound it monthly, so compounded monthly, if I said that's what I wanted, then I know that N would be 12 because there are 12 months in a year. So if I know that my N would equal 12. Okay, so that's just one example. So let's look at an example of a problem, and we're going to use this formula to solve our problem. So reading the problem, it says I want to determine the amount that a $4,000 investment is worth over 3 years at an annual interest rate of 6.4% is worth for the following: compounded annually, compounded quarterly, and compounded daily. So I'm going to do part A right up here. Now in all of these scenarios, our A, we're trying to determine what our A is. That's what we're trying to find because we don't know what that is. So we know then that in our formula, we're going to need to know what our rate is, we need to know what our time is, and we also need to know what our initial investment is. So our rate here says that it's 6.4%. Now 6.4%, we can't write that in our problem. So I know that my rate is 6.4%. Now I know that 6.4% as a decimal is going to be 0.064. Because what I do is I take my decimal place and move it over 2. And so I know that 0.064 is my 6.4%. I know my time when I read in my problem, it says that I'm doing this for 3 years. So my time here is going to be 3. And my P is going to be my initial investment. And it says that I can determine the amount that a $4,000 investment. So I know that my P is going to be $4,000. Now, I'm trying to figure out what my A is, right? What my ending amount is going to be. So what I'm going to do is I'm going to take all this information and plug it into my formula. So remember, my formula is A equals P times 1 plus R over N raised to the NT. So this is the formula we're going to be using all day long. So what I'm going to do is I'm going to take these numbers we just found, and I'm going to say that my A for part A equals 1 plus my R, which is 0.064. Now, we need to figure out what our N is here. So for part A, it says compounded annually. So if we're investing for years, annually means once a year. So if it's once a year, I know my N is going to be 1 for part A, raised to the, now we're going to do N, so 1 times time, which is 3 years. Now I'll enter that all into my calculator, and when I enter that all into my calculator, I get that my investment worth $4,818.20. So after 3 years, my investment I would have gained $818.20 from that investment. So let's look at part B. Now the only difference for part B in this question is it says it's compounded quarterly. So quarterly would mean 4 times per year. So if there's 4 times in a year, that means my N is going to be 4. So my formula from up here is going to look very much the same, except my N here where I have 1, I'm going to replace that with 4 because my compounding rate has changed. So know that A is going to equal 1 plus 0.064 divided by 4 raised to the 4 times 3. And when I enter that into my calculator, I get that's going to be $4,839.32. So that would be my answer to part B. Now my last part would be part C, and again my only difference is I'm compounding daily, so I know that there are 365 days in a year, so my n again is going to change from 4 and 1 in these problems to be 365 in our last. So A is going to equal 1 plus 0.064 divided by 365 raised to the 365 times 3. When I enter that into my calculator, I get $4,846.60. Okay, so that would be my answer to part C. Now I want to look at this really quickly. What do we notice? I had 4,818, then it went up to 4,839, then it went even further up to 4,846. Now, we're looking at this. What happened? We changed our compounding rate. So the more that we compound our money, the more money we're going to be able to get. That's just kind of a general rule, that the more you compound something, the more money you receive. Let's look at another example. So I want to see the question that says, determine the amount that a $14,000 investment over 10 years at an annual interest rate of 3.4% compounding monthly would be worth. So again, I'm going to be using my formula that A equals 1 plus R over N raised to the NT. So let's look. Let's figure out. Do I know what my A is? Do I know what my investment's going to be worth at the end of this time? No, right? That's what I'm trying to find. So let's see what else. Oh, I forgot my P right here in my formula. So let's see. I know my P is going to be 14,000 because that's my initial investment. Let's see. I know my T is 10 years because that's how long it's going to be in there. My R is 0.034 because, again, this 3.4%, I can move my decimal place over 2, and I get 0.034. And my compounding rate, since it says compounded monthly, is going to be 12. So I can just take these numbers, put them into my formula, and I'll get 14,000 times 1 plus 0.034, divide that by 12, and raise it to the 10 times 12, and that's going to give me my answer. So when I enter that into the calculator, I get 19,000, that's supposed to be money sign, $19,659.81. So that is how much money I will have gained for over $5,000, almost $6,000 after 10 years if I just leave this money alone in the bank. And now let's look at one more example. So let's read this one. A credit card charges 20% annual interest compounded monthly on the unpaid balance. If your credit card balance is $300 and you do not make any payments for 10 months, how much will you owe? So I know that A equals P times 1 plus R over N raised to the NT. Okay, so let's see what we know. We want to figure out A, P, R, N, and T. So our rate is easy, right? It says 20% annual interest. So our rate is 0.2. Now, here's where it gets a little bit tricky in this problem. We know our current balance is 300. We want to figure out what A is. So now let's talk about our N and our T. So here, this is where this problem gets a little bit tricky. I know that I'm going to leave this in here for 10 months, right? So my time in this problem is I'm going to put 10 in for my time. Now, if I put 10 in for my time, my compounding rate says I'm compounding it monthly. So that means I'm doing it once per month. But in this problem, since this is 10 months, I know before I've said that compounded monthly means you're going to put 12 in for N, but in this problem, since our time is in months and we're going to compound it monthly, that means our N is going to be 1 because our compounding rate is 1 month. That means every month we're doing it. And since I'm dealing my time is months instead of years like it has been in the past, I know that my N is going to be 1. So let's enter this into our equation here. So that A equals 300 times 1 plus R, which is 0.2, divided by 1 raised to the 1 times 10. And when I type that in my calculator, I get $1,857.52. So let's just talk about this problem for a second. This is why you need to always pay off your credit card bill, because here, you started with $300. If you don't pay it off for 10 months, you owe them $1,500 more dollars. So this is why when you start getting into owning credit cards and starting to have that type of money, make sure that you always pay off your debt, or at least pay off your interest, because if you don't, it's going to accumulate and accumulate and accumulate. So that's going to be our problems today, so go ahead and get started.